Jacob got his. Alexis, you said you got yours. Emma, did you get yours? Emma did. Gavin, did you get your e-ticket? All right, good. So everybody got their e-ticket. That means you're set to go. What I would do, they said that sometimes with all the people entering the exam at the same time, that it's a possibility that like it wouldn't show up or something. So what I would do is make sure that you copy down from that e-ticket like your AP ID and any other information that you would need for the exam. Make sure you write that down or like have it saved somewhere like offline just in case you can't get to it. Just so you know that you have everything and so you can log in. So tomorrow I'll have a brief session that I will record and we'll play at 10 o'clock. So if anybody wants to be on there, I'll make sure that it will be recorded so you can catch it at any time. You can catch it at 10 or you can catch it later as well. But we'll do a brief exam tips and kind of just what you need to be ready for the exam tomorrow. But I think most of you are already in a good shape. You're already ready. But we'll start you need to log in to the exam at 1:30, and then once you've logged into the exam at 1:30, then I would like for you to you'll take it'll ask you some personal questions, and then it will make sure you can do that. No, Emma, you do not have to write with a pen. You can use pen or pencil. They just said dark, so just so people can read it. If you're writing it on paper, just be careful and make sure you practice. If you're doing it with paper, make sure you practice that the file that when you take a picture, sometimes they were saying that some students, their cameras were taking a picture and it was like doing a HEIC or some type of file. And it has to be certain types of files, like a JPEG or whatever. So I would practice that, take a picture of something of your writing, go to the exam demo on collegeboard.org/AP2020 and take a picture of something you've wrote and make sure you upload it just so you make sure it works on exam day. And then don't freak out if something, they have said if something just clearly doesn't work, if for some reason you hit submit and it did not allow the submission, every person has a unique email address where you can send your answers immediately. If you sent them immediately, and College Board would still accept it and you wouldn't have to do a makeup exam. But it should work. Whatever method you're going to use tomorrow, I would double check and make sure that it works just by trying the exam demo so that you're not stressed out about that when it comes time. Okay. And I think whatever you like the best is fine. I don't have any, people have asked me, do you have any preference? Is there one you think is better than the other? It really doesn't matter. How you think you can get the information best across to the reader is the best way, So if you type, good, that's great. So if you type really fast, then, fine. If you think you write it out better, fine. If you'd rather, write it out instead of having to do the symbols and trying to figure out how to do that, and that's fine as well. So any of those things are okay. It's not going to be a big deal. Let me take you to a couple of things before we start today. Without sharing, hold on. The first thing was, there were some readers and other AP stats teachers and stats medic that talked about what they thought, and it's always fun to do this. I did this last year. kind of like a prediction of what they thought the exam would look like, what type of questions they thought it would look like. And so I'm going to, that doesn't mean that this is what it's going to look like or anything, but these are good. They're usually things that as AP Stats teachers, we kind of know they're going to ask you, right? So these are predictions for the AP Statistics exam. So let me show you. This. Let me share my screen with you, and we'll talk about it. So here's some predictions. So it says one of our favorite activities is to make AP exam descriptions or predictions for our students. So like last year, we kind of went through some predictions, and we were like spot on with which one would be which. But sometimes, you know, it's a little bit different than what we think it will be. So it says, so here's what our AP crystal ball is telling us for 2020. So it will cover all 7 units. So because they told us we had to go through units 1 through 7, you can pretty much rest assured that you will get at least one part of a question to cover 1 variable data, which was unit 1, 2 variable data, which was unit 2, collecting data, which was unit 3, the probability, which was unit 4, sampling distributions, unit 5, inference for proportion 6, and inference for mean 7. Of the units, the ones that are more likely to get 2 or more parts would be 1 variable data, collecting data, which is your experiments and stuff, and then the last 2, inference, the hypothesis test and confidence intervals. One second. All right, so question number 1, they are predicting that will be 6 parts. And in question number 2, the prediction is there will be 5 parts. So College Board has communicated that question number 1 is going to be worth 55% of the overall score. And question number 2 will be worth 45%. So if each part is worth 1 point, which we're just kind of saying if there's 11 parts, then that would make this possible, right? Because 6 out of 11 would be 55%, and 5 out of 11 would be 45%. So if you think about that and you think that there's 25 minutes for your first question and 15 minutes for your second question, then it makes sense that students are going to be needing to work just a little bit faster on the second question, but that the first question will probably have more parts in it, right? Your inference questions should look different. In the past, we usually got 1 question where you either had to construct and interpret a confidence interval, so run the whole panic part for confidence interval, or run phantoms, the whole phantoms part for a significance test. There's no room for this in the 2020 exam because that would just cover 1 unit. You know, it wouldn't cover all 7. We need to cover all 7 in the 2 questions. So instead, the exam is likely to ask about specific parts of those procedures. For example, in confidence intervals, they may ask you to define the parameter of interest, to name the procedure that you would use, to check the conditions and explain why we check each condition. So random, because it needs to be randomly selected or randomly assigned. Normal, so that we can use, why does it need to be approximately normal? So there's no outliers, and so that we can say that the data is normal. Independent, so that it doesn't affect the others, so that we have a large enough population. Then they may ask you to interpret a confidence interval. They may ask you to interpret the level. So if the level is 95, that means we're 95% confident that the true mean is contained in this interval, or we're 95% confident that the true proportion is in this interval. And then they may ask you based on an interval if you have convincing evidence. They may already give you the interval and then just say, do you have convincing evidence that this is true? In a significance test, they're typically going to write the hypothesis. They may ask you to write the hypotheses, so the HO and HA. They may ask you to just name the procedure, to check the conditions, to use a test statistic to calculate a p-value. So like if they give you a t-score, you should know you go to normal, or a z-score, you know you go to normal CDF, and you go from there to 999, or if it's going less than, you go from negative 999 to there. They may go ahead and give you a p-value and ask you to interpret it, and they may ask you to make a conclusion based on a p-value that is already done, that's already made. So again, how do you assess a full stats course in just 2 questions? Well, 1 question about means and 1 question about proportions, 1 question that is 1 sample and 1 question that is 2 sample, 1 question that includes a confidence interval and 1 that includes a significance test, 1 that involves sampling and 1 that involves an experiment. So you're definitely going to see like 1 about each type and have different parts in there. How it will be graded: each part of the question should be worth 1 point, and it will be graded as E, essentially correct, P, partially correct, which would be like a half point, or I, incorrect, which would be 0 points. And we are predicting 11 points total. So cutoff values for overall scores of 1 through 5 will be determined by the College Board. So what I talked about was, like, in general, if you got like 1 or 2 points total over the whole 11 questions, let's say you got 2 parts right, you got 1 or 2 total points, then you're going to get a 1. If you got 3 or 4 points, then we'll say, hey, you get a 2 on the exam. Again, those are not passing. Now, if you get 5 or 6 points, then they would say maybe that's a 3, 7 or 8 points is a 4, and then 9 or more would be making a 5 on the exam. So we already went through a specific example of what we thought the 2020 exam might look like. That was the 2020 practice exam that I gave you. So that was an example of what a few teachers and others thought that it would look like, and they thought that the exam would look like. So one final prediction, a 3 is getting credit. So depending on what school you go to, but all UNC schools are accepting a 3, and most public schools in North Carolina, as well as private schools. Now, there are some very high private schools that do not accept a 3, but I can almost assure you that we've gotten to where almost every school will accept a 3 for statistics as getting credit. So one final prediction: with over 200,000 students logging in and uploading answers in that 5-minute window, there will be tech problems for some students where it did not go smoothly. And just remember that that is not a representative sample, right? Because people that have submitted it successfully, the people that have submitted it successfully, that just means that everything went right and they're not going to say anything about it, right? The people that had trouble are the ones that you're going to hear about. So hopefully 99% of people, they say, are getting their exams going through smoothly and everything's going right. So we hope that that will happen for you as well tomorrow. Okay, so let's go and let's take it back to the review course, and let's take a look at Unit 7, which is the significance test. And again, remember, Unit 7 is the last thing that we did. So Unit 7 is the very last thing that we did in the course. We did significance tests for proportions and for means. So let's look at one sample significance test. That's the first thing we're gonna take a look at today. Okay.
Hi, I'm Lindsay from the Stats Medic, and this is video 7.1 on one sample significance test. We're now entering the significance test portion of the curriculum, which is very, very important. All of the AP exams in the past have always had at least one free response question where you're asked to do a significance test. So let's look at the first example. Chicago-style popcorn is a type of popcorn made by mixing together cheddar and caramel popcorn. True Chicago style is composed of at least 40% caramel. A new popcorn shop advertises that they will be selling Chicago-style popcorn. To test this claim, a popcorn lover takes a random sample of 500 kernels of the popcorn and finds that 183 of the kernels are caramel. Do the data provide convincing evidence that the shop is not selling true Chicago-style popcorn? When you're reading through the problems, we still want to be asking ourselves if we have one sample of data or two samples. On this one, we're told we have a random sample of 500 pieces of popcorn, so we know we're doing a one sample procedure. And then the data we're collecting is categorical, so that tells me I'm making a proportion. Now, an AP exam tip is when you are asked to construct and interpret a confidence interval, then of course you should make a confidence interval. But when you're asked, do the data provide convincing evidence, that means you're going to do a full significance test. So just like with confidence intervals, there are 4 parts that you'll need to get full credit on a significance test: state, plan, do, and conclude. For the state portion, you have to, again, identify the parameter, and then instead of a confidence level, we do the significance level. But then what's new now is you need to identify your hypotheses. So in my first hypothesis, should always be an equal to statement. So P, our true proportion, equals 0.40. And then our alternative, since the question said that at least 40% had to be caramel, that tells me that I've got a one-sided test that our proportion is less than 40%. In the plan portion, just like with intervals, we've got to identify the type of procedure and then check conditions. Because we're doing proportions, this is going to be a one sample Z-test for P. And then our conditions are the same as prior to this, so we have a random sample, and then also we're checking large counts. Now, one really important part here, when you're checking large counts, make sure you are checking using your null value. We started the problem by assuming the true proportion is 40%, so when you're checking your conditions, you have to use the 40% and not the statistic that was found.
Quick update here. College Board has recently made some changes to the rubrics for free response questions dealing with inference. When sampling without replacement, we must check the 10% condition, which says that the sample size is less than or equal to 10% of the population size. Here is the work you would need to show for this problem. Let's add this third condition to the plan section for the problem.
Now in the do portion, you maybe throughout the year have been showing lots of work, drawing pictures and such. For bare minimum, you must show a z-score or test statistic and then also a p-value. So I've shown my work here. I've got my sample statistic that was found from the sample of 500 pieces of popcorn, the null value or the true assumed parameter, and then I've calculated my standard deviation below. I've got a z-score of negative 1.55, so that gives me a p-value of about 0.06. And lastly, you need to conclude for your test. Now, an AP exam tip, they'll be looking for 3 things. The first is that you must be linking your p-value to the significance level. So you have to explicitly tell whether or not your p-value is greater or less than your alpha level. You must always have context in a conclusion, and then you need a final decision about the alternative hypothesis. So because our p-value of 0.06 is greater than our alpha level of 0.05, we will fail to reject the null. We do not have convincing evidence that the shop is not selling true Chicago-style popcorn. So we've addressed our context in here, and then the alternative hypothesis I put back in context as well by saying they're not selling true-style Chicago popcorn, that's saying the proportion is less than 40%. So let's check out one more example. Last year, an AP Stats class spent an average of 25 minutes a night on their homework. Their teacher randomly sampled 30 of her students this year to see if this average was still true. The sample had a mean of 32 minutes spent on homework each night and a standard deviation of 11 minutes. Do these data provide convincing evidence that the AP students spend more time on their homework per night this year compared to last year? So a few things I noticed as I read through again, I'm still just looking at one sample. It says she takes a random sample of 30 students. And then also they mention in there's a sample mean. So even though they didn't actually ask us in the question about a mean or proportion, by giving us a mean, they've clued us into that. So let's go through the 4 steps for this problem. Since it asks if there's convincing evidence, I know I'm doing a significance test. When defining my parameter, I've used the notation of mu as the true mean time spent on homework each night. I should also probably mention that that is this year. And my null hypothesis, then we've got, again, an equal to statement, mu equals 25, and then they've asked us if the sample this year is greater than last year. So I've got one-sided that the mean this year is larger than the 25 minutes. Checking conditions, I've got random sample again, central limit theorem, and then make sure you identify your procedure. This is a one sample t-test for mu.
When sampling without replacement, we must check the 10% condition, which says that the sample size is less than or equal to 10% of the population size. Here is the work you would need to show for this problem. Let's add this third condition to the plan section for the problem.
Little things to note here and there, with means instead of proportions, we should be using a t-test statistic, not a z. So my test statistic of 3.48 gives me a p-value that's very small, 0.0008. So because this p-value is so small, smaller than our alpha level of 0.05, we reject the null hypothesis. And we have convincing evidence that the students this year spend more time on average doing their homework than last year's students. Again, I've made a final decision about my alternative hypothesis. So we've said that the students do spend more time. And then I've also used context. So I know that I've gotten my full points on my conclusion.
Okay, so that gave you just a little bit of insight into one sample, and there was one with one proportion and one also with one mean. So does anybody have a question on those with one proportion or one mean? You're just basically seeing that you need to make sure you look in the problem and see if it is a less than, a greater than, or a not equal to, so that you know what you're doing. And remember, you can always go to stat test and work through getting the test statistic and the p-value. And then you want to look at your significance level. And if your p-value is less than the significance level, you reject HO, which means there is sufficient evidence in the alternative. If your p-value is above the significance level, you fail to reject HO, which means there is not sufficient evidence in the alternative. Okay, so that is kind of a brief rundown of that. If they don't give you a significance level, we assume that is 0.05. Just like if they don't give you a confidence level, we assume that is 95%. However, if they do give you one, then you'll follow the one that they give you as well. Okay, so let's look at when we do the normal condition, do we use the statistic or the hypothesis? Let's see, in what problem would we be talking about? Oh, so we're talking about here. If you notice here, you're using the hypothesis in the normal condition. You're using your HO and HA. So you're using, you're always going to, so an easy way to remember that, Alexis, is you're always going to use P for the population if you have it. If you don't know the population P, then that's when you would use P hat, which is your statistic. So you're always going to use P, which is the population, if you know it. And what happens is when we're checking those conditions in confidence intervals, a lot of times they don't give us the population. So we had to use the statistic. But when we're checking them in, when we're checking them in the online, in the significance test, then they've given you a population to see if it's less than or greater than. So we're going to actually use P for the entire population. All right, so let's go to the 2 sample.
Hi, this is Lindsay from the Stats Medic, and this is video 7.2 on 2 sample significance tests. At this point, we've been through 1 sample and 2 sample confidence intervals and 1 sample significance test, so this rounds us out. Let's look through our first example. 2 rival universities are both claiming that their graduates are more likely to gain employment within 3 months of graduation than those who graduate from the other school. A random sample of 500 recent graduates from College A revealed that 460 had employment within 3 months. A separate random sample of 400 recent graduates from College B showed that 342 had gotten jobs. Do the data provide convincing evidence that there is a difference in the proportion of graduates who had employment within 3 months from College A and College B? So to get full credit for a significance test, you need to hit the 4 points: state, plan, do, and conclude. In my state portion, I have identified both of my parameters separately. You could do that all in one step as P sub A minus P sub B. Personally, I like to keep them separate. And then our hypotheses, I'm using the format of P sub A minus P sub B equals 0. An alternative is you could say the proportion of A equals the proportion of B. That would be fine as well. And then in my alternative, I have P sub A minus B does not equal 0. Now, an AP exam tip is when the question is asking if there is a difference in proportions or means, that means we're doing a 2-sided test. Now for my alpha level, they actually didn't give me one in the problem, so a general rule of thumb is to use alpha equals 0.05 when you haven't been told one. Onto the plan portion, identifying my procedure. This is a 2-sample Z-test for PA minus PB. Random, the data is coming from 2 independent random samples.
I just want you to notice, I'm going to jump in here. When they do PA minus PB equals 0, that's the same as us saying PA equals PB, right? And PA is not equal to PB. You don't have to do this subtraction thing and have a 0 in your hypothesis. The same thing as saying P1 equals P2 and P1 is not equal to P2. Okay.
Make sure you mention that part about it being independent samples. And then the normal condition, checking large counts again. I've gone through and checked all 4 of my proportions that are needed, and all of them are greater than or equal to 10.
Quick update here. College Board has recently made some changes to the rubrics for free response questions dealing with inference. When sampling without replacement, we must check the 10% condition, which says that the sample size is less than or equal to 10% of the population size. Here is the work you would need to show for this problem. Let's add this 3rd condition to the plan section for the problem.
Now for the do portion, things get a little bit tricky here when you're doing a 2-sample Z-test. So I've gone ahead and shown all my work, and you maybe have noticed here.
And also remember, in this do portion, you can just go to 2-sample test on your calculator and get the Z-score and the p-value. So you do not have to go. You can do 2-sample or 2-proportion Z-test. You do not have to show that full formula with all the numbers. So that will save you some time if they ask you to calculate the Z-score and the p-value.
I have these values that actually don't match any of my statistics. Those are the p-combined values, which sometimes people make mistakes on. So an AP exam tip is you actually might not want to show work for this type of test. You could, but again, if you show work, you need to make sure that it's correct, which means that you need to use your p-combined value here instead of your separate p-hats. So I've gone through and have all my work calculated. Again, if you weren't going to show your work, you could do a 2-prop Z-test in your calculator, which will give you a Z of 2.064 and a p-value of 0.039. Last, to wrap it up, we need to conclude, again, just like with the 1-sample test, we need to make sure that we're linking our p-value to the significance level, that we have context, and that we make a final decision on our alternative hypothesis. So because our p-value of 0.039 is less than the alpha of 0.05, we'll reject the null hypothesis. We have convincing evidence of the alternative. Now here, when you're writing your conclusion, something that's very helpful is to use the stem of the problem. So in the problem, we are asked to decide if there's a difference in the proportion of graduates who had employment within 3 months from college A and college B. So what I've done here is I actually just said, yes, we do in my conclusion. That's a really nice way when you're doing the two proportion test to make sure that you've answered the question completely and you haven't changed orders or anything like that. All right, so let's look at one final example for a two sample significance test. Last year at East Kentwood High School, there were 650 students who took the geometry final exam. School gave two forms of the exam which were randomly assigned to the students. Half of the students took Form A and the rest took Form B. After the exam, some students claimed that Form B was more difficult than Form A. To test this claim, the principal took random samples of 30 exam scores from each form and recorded the score. The results are shown. Do the data provide convincing evidence that the mean score on Form A was higher than the mean score on Form B, using an alpha of 0.01? So let's look through and find the important parts of the solution that's worked out. So in state, I have, again, both of my parameters defined separately, and in my hypotheses, this is just going to be a one-sided test. We are looking to see if Form B is more difficult, meaning that Form A would have had a larger average. In the plan portion of identified our procedure, make sure you're marking these as t-tests when you're doing means instead of a z-test for proportions. And in the random condition, we have actually two pieces that we need to satisfy our random condition. So we're told in the problem that the data is coming from independent samples. So I've got that marked here, independent random samples. The reason that's important, with random sampling, we can generalize to our whole population. But we're also told in the problem that the forms had been randomly assigned to students. Random assignment is what allows us to determine causation, which will allow us to decide if the form is what was causing the difference in scores as opposed to some sort of confounding variable. And then for the normal condition, you should show that both samples have satisfied the normal condition. So even though it's about 30 and 30, you should show it for both parts. Then we go ahead and calculate our test statistic. You get a t of 1.31, which gives us a p-value of 0.098. So in our final conclusion, remember we're linking our p-value, giving context and a decision about the alternative hypothesis. So because our p-value of 0.098 is greater than our alpha of 0.01, we fail to reject the null. We do not have convincing evidence that the mean score on Form A is higher than the mean score on Form B. And again, I just used the phrasing from the context or the phrasing from the question to write my final sentence here. Really everything from here on is coming directly from the problem.
Okay, does anybody have a question on the two sample significance test? So that would be for two proportions or for two means. So we'd be looking at two proportions or two means. Any questions about that? Remember, this chi-squared and linear regression is not on the exam. So Gavin, so when we're dealing with proportions, the normal condition is n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. When we're dealing with means, the central limit theorem just says n needs to be greater than or equal to 30. Okay? So when dealing with proportions to check the normal condition, we have to check, it's called large counts. It basically makes sure our sample is big enough. We check np greater than or equal to 10 and n1 minus p greater than or equal to 10. And let me type this in the chat. So for proportions, we say np greater than or equal to 10 and n1 minus p greater than or equal to 10. Now, for means, we do number one, we say, is the population normally distributed? If the population is normally distributed, then we can say that the sample is as well. Typically, we don't know that about the population, so we go to the second thing for means, which is the central limit theorem says our sample must be at least 30. And then if for some reason it doesn't pass that either, then our third one is if we have data, there are no obvious outliers that also pass the normal condition. So in proportions, it's pretty straightforward. It needs to be NP greater than or equal to 10 and N1 minus P greater than or equal to 10. For means, you're looking at, is the population normally distributed? We typically don't know that. So we go to the central limit theorem and say, is our sample at least 30? If it is, good, we've got the normal condition. And then if for some reason it's not, we go to our next possible thing and we say, are there any obvious outliers in there? If there's not any outliers, then it can still pass the normal condition. And that's for means. So hopefully that cleared that up with it as well. So let's go to, we're going to move. So that was, let's look at type 1 and type 2 errors real quick. And then we will try to do one significance test before we move forward. Okay?
Hey, this is Luke from the Stats Medic, and this is video 7.6 on type 1 and type 2 errors, as well as power. So we're going to start this video out with some context from an example problem. Tacos El Cuñado claims that their giant burrito is half pound on average, more precisely 8 ounces with a standard deviation of 1.0 ounces. Luke believes the average weight is less than that. He thinks it's 7 ounces. To test his claim, Luke goes to Tacos El Cuñado and takes a random sample of 5 burritos. He will test the claim with an alpha level of 0.05. So let's start by taking a look at the hypotheses. In this case, the null hypothesis is going to say that the mean weight for the giant burrito is equal to 8 ounces, the claim made by Tacos El Cuñado. The alternative hypothesis is that the mean weight for the giant burrito is less than 8. So let's first, before we get into the idea of thinking about errors, think about what would be the correct decision to make in each one of these scenarios here. So in the first scenario, we're going to say that the giant burrito really does, in fact, average 8 ounces. So if Luke is going to perform a significance test, what would the correct decision be here? Well, in this case, if the null hypothesis is true, then Luke would want to fail to reject the null hypothesis. So the correct decision here is to fail to reject the null hypothesis. Now, on the other hand, if the reality is that the giant burrito really does average less than 8 ounces, well, in this case, if Luke were to make a correct decision, he would reject the null hypothesis. So in both of those cases, Luke has made the correct decision. Now let's talk about what an error might occur in Luke's thinking here. In the first case, the error would be if the giant burrito really does average 8 ounces, but Luke rejects the null hypothesis, right? That would be an error. This is what's called a type 1 error. In the second case, if the giant burrito really does average less than 8 ounces, the error in this case would be to fail to reject the null hypothesis. This is what's known as a type 2 error. So let's try and formally define what a type 1 error and a type 2 error is. The type 1 error, the first case here, is when the giant burrito really does average 8 ounces. Well, this means that the null hypothesis is true. In the second case, the giant burrito really averages less than 8 ounces. That would be that the alternative hypothesis is true. And that's for the type 2 error. So that's given that the alternative is true. So here's a very easy way for you to keep track of the difference between a type 1 error and a type 2 error. For a type 1 error, we're given that the null hypothesis is true, whereas for the type 2 error, we're given that the alternative hypothesis is true. Now, the second part of these definitions is to think about the decision that was actually made, and you have to keep in mind that we're making an error here. So if the null hypothesis is true, the error would be to reject the null hypothesis. So given the null is true, but we reject the null hypothesis, that is a type 1 error. And for the type 2 error, we're given that the alternative is true here, but we've made the wrong decision or made an error and we've failed to reject the null hypothesis. So in this case, failed to reject H null. So here's your AP exam tip on this one. When interpreting a type 1 or type 2 error, treat it as a fill-in-the-blank exercise. So for example, the type 1 error in this case would say, given that the null is true, we reject the null hypothesis, but you're going to fill in the blanks, and it should look like this. Given the giant burrito has a mean weight of 8 ounces, we reject the claim that the mean weight is 8 ounces. For the type 2 error, we're given that the alternative is true, and then we failed to reject the null hypothesis. In this context, it would say, given the giant burrito has a mean weight less than 8 ounces, we failed to reject the claim that the mean weight is 8 ounces. So now that we understand the definition of a type 1 and a type 2 error, let's see if we can figure out how that would fit into this visual representation of these ideas. So the way this is organized here is that we'll start by thinking about the actual truth. And there are two possibilities. Either the null hypothesis is true, or the alternative hypothesis is true. Now we know for a type 1 error that the null hypothesis has to be true, and we've made the wrong decision. In this case, that would be rejecting the null hypothesis. So we know that the type 1 error is going to go in this spot right here. So one of the things that you need to be able to calculate is the probability of a type 1 error. And this is very easy. The probability of a type 1 error is just equal to the significance level alpha. So for the giant burrito problem, the probability of a type 1 error would be 5%, or 0.05. Now, on the other side of this diagram, we have the truth being that the alternative is true. And if we're making an error here, this would be failing to reject the null hypothesis, which we defined earlier as being a type 2 error. Now, there is one other term that you're going to need to be familiar with from this table here. In the event that the alternative hypothesis is true, and we've made the correct decision this time to reject the null hypothesis, that's what's called the power of the significance test. Now, it's important to recognize that the power of the significance test.
Okay, so I'm going to stop this one right here. So in your little box, if HO is true and you reject HO, you've made a type 1 error. And whatever the significance level is, that's the chance of you making a type 1 error. So if it's 0.05, there's a 5% chance of you making a type 1 error. Whenever HO is true and you fail to reject HO, then you have made the correct decision. Whenever HA is true and you reject HO, you have made the correct decision. And whenever the alternate is true but you fail to reject HO, you have made a type 2 error. So if you reject HO but it's really true, that's a type 1 error. If you fail to reject HO and it's really false, that's a type 2 error. Okay, so those are the two that you really want to pay attention to. That could just be one part on a test. I still don't anticipate that being there, but it is possible, right? That it could be. It's one thing that could be on there. All right. So let's look at if we've already. So as we look at this one, we've already done this problem. So I'll talk about it real quick. But together in class, we did 2015 question number 4. So a researcher conducted a medical study to investigate whether taking the low-dose aspirin reduced the chance of developing colon cancer. There were 1,000 adult volunteers who were randomly assigned to one of two groups. Half were assigned to be an experimental group who took a low-dose aspirin each day. The other half were in the control group who took a placebo each day. At the end of 6 years, 15 of the people who took the low-dose aspirin had developed colon cancer, and 26 who took the placebo had developed colon cancer. At the 0.05 level, do we have convincing evidence? So again, the parameter of interest is we are interested in the proportion of adult volunteers that developed colon cancer and then we're looking at whether they took a low-dose aspirin. So P1 would be the group that took the low-dose aspirin, and P2 would be the proportion that developed colon cancer that took the placebo. We go through the P1 equals P2 would be our null hypothesis. Our alternate would be that P1 is less than P2 because we want less people, right, to develop colon cancer. want it to reduce the chance. Random, it says that it was volunteers. The 1,000 adult volunteers were randomly assigned, so it is random. For the normal condition, you have 15 and 485 in the first group in your successes and failures. In the second group, you have 26 and 474 as your successes and failures. Because remember, you're splitting them in half, so there's 500 in each group. So it did pass the normal condition, the NP greater than 10 and N1 minus P greater than 10. You had to do that for both of them. And then for independent, we assume there are more than 10,000 adult volunteers similar to these. So that would be your independent condition, which means it's bigger than 10 times the size of your sample. Now, the next thing as we go through, you would go to your calculator and we would work on doing a 2 proportion. So let me share my calculator with you. We would work on doing a 2 proportion, a 2 proportion Z test. So that's what we would want to do. We would want to do a 2 proportion Z test. All right, so let me pull this up. So we would go to stat test. You would go to 2 prop Z test. In the first one, we said that 15 out of 500 developed colon cancer. In the second one, 26 out of 500 developed colon cancer. We want to see if the first one is less than the second one, and we want to calculate it. You get a Z-score of negative 1.75. You get a p-value of 0.0396. If you notice from the problem, it said the significance level was 0.05. So we would say because the p-value of 0.0396 is less than 0.05, we reject HO, and there is sufficient evidence to suggest that, and then we go back to the problem, there is sufficient evidence to suggest that taking a low-dose aspirin each day would reduce the chance of developing colon cancer among all people similar to the volunteers. They do not want you to know the probability of making the type 2 error, Emma. You just need to know what a type 1 error and what a type 2 error are. So you just need to know that a type 1 error is when you reject HO when it's really true, and you need to know type 2 error is when you fail to reject HO and HA is really true. Okay, and again, those have very small probabilities, I would say, of being on there just because they're one little part. I would say you're going to get these big ideas such as the significance test and confidence intervals probably is more likely, but anything can occur. So, you know, we do want to look at that. All right, so the last one, the Unit 7, here's a free response. This one was the one that's not going to be on the exam. So that was the chi-square. So let's move. It says not assessed on the 2020 exam. So let's move to, and then the multiple choice. If you want to work on the multiple choice, you definitely can, but we're going to look at the free response question. So here we go. It says an online streaming service providing television programs claims that a 30-minute program will stream with advertisements that average 45 seconds. A consumer advocacy group is investigating to see if this claim is true. They recorded the times of 21 randomly selected assignments and the advertisements. And then there's the 21 advertisements. And then it says the mean and standard deviation for these times are 46.67 and 2.78. So they've given you the sample mean and the sample standard deviation. Did these data provide convincing evidence that the mean advertisement length is longer than 45 seconds? So let me go through this really quickly. Hypothesis. So the parameter of interest is the mean advertisement length for a 30-minute or for an online service providing television programs, okay, in a 30-minute program. So it's the mean advertising length in a 30-minute program. That's our parameter of interest. Our null hypothesis is that mu equals 45, right? So it's 45 seconds. The alternate hypothesis would be that mu is greater than 45, and that comes from this right here, because we're trying to find if there's evidence that's longer than 45 seconds. So it would be that mu is greater than 45. So that would be our alternate hypothesis. Then we would go to our assumptions, random. We would say 21 randomly selected advertisements. Then we would go to normal, okay? It does not pass, so we don't know that the population is normal. It does not pass the central limit theorem because 21 is not greater than or equal to 30. So we look at our advertisements, our data, and we see that they're all fairly similar. There's none that are way far away from the others. So for the normal condition, we say there are no obvious outliers in the data. So that will make it normal. Then we go to independent. We say we assume more than 210 advertisements, right, in the population. So we assume there's more than 210 or at least 210 advertisements in the population. And now we can name our test. So our test, this is a one sample t-test, right? Because we don't know the standard deviation of the population. So we're almost always with mean going to do t. This is a one sample t-test. And then we need a test statistic and the p-value. So let me go to my calculator. And we go to stat test. And we go to t-test. And we have we actually have the statistics. So the mean is that it's 45. That's the null hypothesis. From our sample, the mean is 46.67, and the standard deviation is 2.78. Our sample size in this problem is 21, and we want to see if it is greater, right, than 45. So we are going to calculate. And from that, we get a test statistic, which is a t-score of 2.75. And then we get a p-value of 0.0061. So we say, because the p-value of 0.0061 is less than any alpha level, but in this problem, it did not give us a 0.05 or 0.01. We could say because it's less than 0.01 even, we reject HO. There is sufficient evidence to suggest that the true mean advertisement length is longer than 45 seconds. So because our p-value of 0.0061 is less than 0.01, which would be the lowest alpha level you could use, we reject HO, which means there is sufficient evidence to suggest that the true mean advertisement length is longer than 45 seconds. So we're able to go through that problem. So basically, I mean, in general, as we look through these with significance tests, you guys should feel pretty solid about it. Everything's going to be either proportions or means, right? So we have confidence intervals for proportions and means. We have significance tests for proportions and means. Again, we have 7 units. Every unit's going to get a part of a question somewhere. There'll probably be 11 parts total between the 2 questions. So if you think about it, if every unit gets a part, unit 6 and 7 getting 2 parts is pretty likely, because this is a big topic, right? Is confidence intervals and significance tests. So if there's 2 parts from unit 6 and 7, that gives them 4. And then units 1 through 5 all have 1. Now you're at 9. So then you think, well, where's the other big parts going to come in? Probability was a really large unit. I think that's got a chance of getting an extra one. And then all the way back in unit 1, right, with like 1 variable data where you just describe the distribution, the SOC. Like you're almost guaranteed to see that shape, outlier, center, spread. You see describe the distribution. You know you need to deal with the shape, outlier, center, and spread, and in the context of the problem. So that's going to make up your 11 parts. So there shouldn't be any tricks here. as you go through that. Everything should be fairly